All right, so we are going to talk a bit about using AWS and open data to meet demands of disaster response situations. So I'm going to lead off with a little bit of an overview of some of the things that I've been thinking about recently along these lines. And then I'm going to bring up Tyler Radford, who's the executive director with Humanitarian OpenStreetMap team. So if you were in our first session around transportation, you would have seen OpenStreetMap come up there. And then it'll come up again here today. So I think one of the first things I want to start about is open data is in the session title. So why do we care about open data? I think this is one of the most common questions that we get a lot when we go around and talk about open data. And I think it's easy, from our perspective, we care about it because our customers care about it, right? So we have a large number of generally public sector customers who are looking to make a lot of data available in the cloud in efficient and optimized manners. And the reason that they're looking to do that is because we have a large number of customers on the other side, on the demand side, who are looking to use that data in the cloud. And if you were just in here for the excellent previous talk, that was generally about how to make and why they're making their data available in the cloud for their customers to use. When you can do the processing next to the data sitting in the cloud, it's a much better process for everyone, both on the supply side and the demand side. So we look to figure out best practices in a number of ways. And we have a public data sets program that we run through the open data team, and we make a number of data sets available here. And generally, when we think about this, we think to ourselves, we're trying to make the more data more available to more people. So you can see more about the open data program there. If you're looking for particular data sets, we launched the Registry of Open Data on AWS about a month or two ago. And you can find not only the data sets that we've sort of curated and worked closely with a number of our customers to make available, but also data sets that other groups are making available themselves in the cloud on AWS. And so these are groups who have a mission or mandate to make their data available, and then they themselves can go and register their data sets there. So it's a good place for you to go look if you're looking for data sources to use, but also if you're looking to make your data more widely available, you can go here and self-register. We also have the Earth on AWS initiative, which is the way that we try and coalesce all our geospatial data sets and activities in one place, so it makes it easier for you all to go and see what is available. And so if you go here, you will see a number of our large geospatial data sets that we make available in the cloud, like Landsat, Sentinel-2, Sentinel-1, MODIS data, NAPE, USDA, aerial imagery, 1-meter imagery, data sets like OpenStreetMap. And so one of the things that I thought about, and I think this was actually during the holidays 2 years ago now, sort of had some free time, and I wanted to think of how to bring some of this together in a prototype in a meaningful fashion, right? Because I sit on a team that has access to sort of this 10 petabytes of freely available data, a lot of it very useful geospatial data, but it still takes, there needs to be a piece to make it useful for people, right? And so I sort of came up with this idea of I wanted to bring some prototype together that would provide meaningful, actionable information as quickly as possible to respond to disaster situations arising from earthquakes, right? And as an aside, for any of you sitting in the back of the room, I don't know if it's the same in the front, there's a very weird vibration going on in the back of the room. I don't know if there's traffic near us, but it feels a little bit like an earthquake. So it's very interesting, just so for all you people in the back. So what is this that I sort of had in mind? I just wanted to be able to get data to sort of first responders as quickly as possible, right? And so I sort of thought about a blueprint of what this would look like. And I'm just going to step through a number of these little segments here. And so first of all, if you're looking at the diagram that you see here, for those of you who are familiar with AWS and step functions, you'll notice that this is just a step functions outline. So step functions is a service that basically lets you set a programmatic blueprint to fire off different functions, and it can handle failures and retries and logic like if-else's or waits or parallel states. And so all of these things will fire off in the manner that I set them to do. And so the trigger for this step function is coming from the USGS earthquake feed. So there's currently an RSS feed, which is something that I set up a mechanism to poll. I used a Lambda function to poll this RSS feed and turn it into an SNS feed. which is something that we use in AWS to trigger things programmatically. So there can be any number of listeners to this SNS feed. And so what I did was say, anytime that there's a new earthquake that happens around the world, I will run the step function, right? And so what does this step function do? So we'll start walking through some of the steps of this step function. So the first thing that it does is it checks magnitude. Again, keep in mind, this is all a simple prototype. This isn't like a well-baked solution that I'm trying to get anyone to actually use. It's just sort of a way for me to think about how the various open data sets and services that we offer can be used in a disaster response situation. So the first thing I do is I check magnitude. I say if it's above a 5.0, then start doing something. If it's below a 5.0, it's not of interest, right? And so just end, the step function is done. And remember, this happens within seconds of the data being made available through the USGS earthquake feed. So the first thing we do is we start collecting imagery from open sources, right? And so as I mentioned, through the Earth on AWS initiative, we've got data like Sentinel-2, which is optical data, Sentinel-1, which is SAR data, Landsat, which is also optical data. And they're all sitting there in their sort of multi-petabyte catalogs. But we don't need all of that data, right? We only need a small piece of it. And so if some of you saw Element 84's talk at the Earth and Space event, they started talking about these sort of archives of convenience. You could think of this as a similar thing, which is what we do is we say, if it's above a magnitude 5.0 earthquake, I will grab the imagery over the epicenter. I will grab the latest 3 somewhat cloud-free scenes. And this is actually, I'm literally waving my hands now, because you could set up this logic to be whatever you wanted, right? So I think I said, give me the last 3 images with a cloud cover under 20%, and I will copy them over from the archive and stick them in an archive of convenience, to borrow a term, and it is in a bucket that is ready for you to use immediately, that you can share with anyone, right? It's publicly available. It was already publicly available data, but now it's just publicly available in a smaller scale, just those images that you need. So again, within seconds, you now have access to all the pre-event imagery that you could want from a number of these open sources. There's nothing that would prevent you from doing this with, say, high-resolution commercial imagery sources. That would just be a different chunk of code, and of course, for the prototype, I didn't put that in. So what can you do once you have that imagery available? Well, there's a lot you can do with it. If you're making the imagery smartly available in a number of formats, cloud-optimized formats, this here is working on top of something called cloud-optimized GeoTIFF, but there's a number of cloud-optimized formats. And what you're seeing here is a tile server. And so this is a Slippy map if you're used to the web development world. It's just a map that you can move around. And you start to see the imagery tiles coming in. And keep in mind, this could be sort of lower resolution data or moderate resolution data, or it could also be high resolution data, so you can see exactly what's going on in the ground. But the thing to remember here is that this is actually running in a serverless fashion. So if there's no disaster, if there's nothing in this bucket and nobody's using it, it doesn't cost anything. So it's only when you start making web requests to power your interface, your browser UI, and you start making the requests to get this data, that's when you start paying. But as soon as you're done, pre or post-disaster, there's no cost for any of this, right? So it's basically a service, just like all of our services, that you only pay for once you start using it. But you can use this for more than just visualization. You can also use it for analysis. So this is work from Synergize that they've done doing analysis. Greg, I know you're here in the audience. I think this is Sentinel-2, most likely. OK, he gave a nod. Good. So this is using serverless functionality to do analysis on the data, right? And so again, the type of analysis doesn't really matter. This is just sort of throwing out some ideas. But the same thing applies here. If you make the data smartly available in the cloud, you can use functionality and functions that only spin up when you start making the requests to allow you to do on-the-fly analysis. So you didn't have to go through a lengthy process of pre-processing anything or caching anything. You can do this all on the fly within seconds of the disaster striking. So something that we're going to talk about that came up in an earlier session, I mentioned OpenStreetMap. OpenStreetMap is a base map of the world. So it's building footprints, roads, points of interest. One thing that you might want to do around an epicenter is say, where are all the hospitals? So this comes from work that Seth Fitzsimmons did around getting the OpenStreetMap data into the AWS Public Datasets program. It was made available in a columnar format so that it's very easily queryable. And so you can programmatically, or you could write by hand, a query like this that says, give me all the hospitals around Guinea, Sierra Leone, and Liberia. Or you could just do it around an epicenter, obviously. And so from the earthquake feed, we know where the earthquake is happening. And then again, within seconds, we can say, here are all the hospitals within a 100-kilometer radius. And depending on how the data is tagged, you can also say these are their qualities, or these are the sort of facilities that they have available. And then, of course, you could also do something like programmatically start sending them notices to be on alert. And sort of anything is possible again, right? Waving my hands a lot here. And I think the other important thing to notice is that, and this might come up when Tyler talks in a bit, is that with OpenStreetMap, we don't own that map. The community owns that map, right? And so you could imagine efforts, and there are a number of groups that do this. You could imagine efforts that if you're looking at disaster-prone areas, you can have groups go in and pre-update the map, right? So that the map is in the best possible position for when a disaster strikes. Because obviously, you can query the map and get all the data you want, but if it's not up to date, it's not helpful, right? In fact, it's probably even worse than not helpful. So this is just another example here. This is looking at building quality. So again, you could look around the epicenter. You could look at the building quality to get an idea of what state the buildings were in pre-event. And this could be useful as a metric to wonder how many buildings might have been most affected by the event, right? So obviously, if the building structure isn't a very good quality, you might say, okay, this isn't maybe one of our initial targets to look at for further study. And again, all that data is within OpenStreetMap. So you could also run machine learning machine learning models on the data. This was definitely something I wanted to do, but it did not happen. So what I'm going to do instead is talk a little bit about other groups that are using AWS to sort of promote the state-of-the-art with machine learning around this sort of imagery, right? And so this is a group called SpaceNet. It's a collaboration between CosmicWorks, Radiant Solutions, and NVIDIA. And it's a machine learning corpus of aerial imagery. So currently it's just satellite imagery, but you could imagine aerial imagery, drone imagery, so plane imagery, drone imagery could also go in here. They also run challenges around the data to get people to open source their algorithms for better machine learning purposes, right? So they're trying to get groups to open up their algorithms to better detect buildings, roads, points of interest. To date, they've given out a little over $100,000 in cash prizes to incentivize people to work on this. This data is all available on S3. The newest challenge that's coming up, if you're familiar with satellite imagery, a lot of it's taken straight down. They're going to see how far off straight down you can take the imagery and still have your machine learning models work. Because the idea is if you don't need an image that's straight down, in a disaster response situation, you can probably get an image much quicker because you don't have to wait for the satellite to be directly overhead. And so if your machine learning models work when your image doesn't need to be straight down, then you get imagery much quicker and start to respond much more quickly. There's also work from groups like Development Seed, who are doing open source work to do a number of these same sort of analyses. One other thing that's very interesting, remember AWS has a broad breadth of services. So I just kind of threw this one in here because I think it's fascinating, and we actually did this with American Red Cross. You could, in an automated fashion, spin up a call center. So one of the things that starts happening around disasters is people start calling the phone lines, and they generally don't have the capacity to handle that. So with the American Red Cross, we actually spun up using a service called Amazon Connect. We spun up a call center. We actually volunteered to staff the phone lines in that scenario. You can use technology to do this. You can use things like Lambda functions to provide voice interfaces. But we volunteered and provided people on the lines. But then once the disaster is done, the call center goes away, and you're not paying for it anymore, right? And again, all of this stuff can be done in an automated fashion. But there's probably a lot of things that you could do that you don't want done in an automated fashion. So step functions also allows you to basically put a human in the loop. So if there's certain processes, like if you're doing a large-scale people deployment, you probably want somebody in the loop to say, yes, we should deploy people, or no, we should not deploy people. And you can also put these into your step functions as well. So the sort of last thing that I want to talk about is actually something that we have a demo of up in the expo hall. We worked with a drone deploying humanitarian OpenStreetMap team to sort of put this prototype and the demo together, is you can deploy sort of a little mobile response center into the field, right? So we have something called the Snowball Edge, which is around, it's 100 terabytes of storage with compute on board. It's a hardened case. It just runs off of normal power. I'm sure you could run it off a generator, but it's rain and dust resistant. And so what you can do with this is actually run an interface off of it to display satellite imagery, drone imagery that's coming in. You could have pre-event data that's loaded onto the box when it leaves one of our facilities. Because remember, a lot of our customers, or maybe I'll put this the other way, a lot of the groups that are flying high-resolution satellites are our customers. A lot of the groups that have sort of globally spanning large satellite imagery data sets are our customers. So a lot of that data is already sitting in S3. And so you can ship one of these from one of our regions, and they can go out with up to 100 terabytes of data already on them. So this isn't data you need to access in the field. This device can be shipped to the field with the data already on it. And then if you're doing drone overflights in the field, that data can go right onto the box. You can use something like OpenAerialMap to act as an interface to look at that data in a cohesive manner. You can use something like Portable OpenStreetMap to do field enumeration. So you can do wellness checks, right? You can update the map on the fly, and then that can be put back into the system. So when you need to route people for first response situations, they can be routed using the most up-to-date data that you have available, because you have people on the ground updating it without any external network connectivity, and it can go right back to the box. So here's an example of the drone imagery coming in. We can see using OpenAerialMap as an interface for looking at the data side by side. This is pre and post from the Hawaiian volcano that's going on. You can use tools like QGIS, right? So you can use local sort of laptop, desktop analytics software in the field running off the Snowball Edge. And like I said, you can use Portable OpenStreetMap POSM to update the maps in the field. You can use something like OpenDataKit for field enumeration, wellness checks. That will also go back to the Snowball Edge. And then you can reroute based on that. And finally, once you collect all this data, you can have that sent back to our data centers, where it'll end up in an S3 bucket, so that this data isn't stuck on the device. The device was initially intended as an import or export device. So you can use it in the field, and you can use a cluster of them as well. They're not stuck to just being single ones. And then you can ship them back to our facilities, and they will end up in an S3 bucket of your choosing. So if you're interested in seeing any more of these pieces, there's some links up there. There's another talk this afternoon around a similar concept, coming at it from a different angle. So I would suggest you check out that. And then up in the expo hall, there's the disaster response team booth. You should come by after this. I think what time? I think the expo hall closes around 1. I think that's. So I guess there's not a ton of time, but you should check it out, because I think, Seth, is the demo still up there? Is that? Yeah. Okay. Yeah. So the demo's still up there. So you should stop by the booth and check out the demo if you want to see some of this actually working. So that's all I have. So with that, I want to invite Tyler up to talk about the work that Humanitarian OpenStreetMap team is doing. Thank you.
Thanks, Joe. Very good morning to everyone. I'm really happy to be here today. Before I start talking, I was just thinking a little bit about it on my train ride down from New York this morning. Was looking at my phone and sort of being bombarded with the typical news stories that are coming out every day, and just feeling a bit overwhelmed and a bit depressed, and just kind of feeling this deluge of bad information coming in. And I was thinking about my talk today and how volunteers and people around the world are kind of making breakthroughs, and there's little glimmers of hope. And so what I want to talk to you all about today is one of those stories. It's not my story. It's the story of thousands of volunteers coming together to do something that many of us didn't even know was a problem, and that's mapping unmapped areas of the world. And they're doing this and being powered through AWS solutions, and I'll tell you a little bit more about that. Let's see if I can move forward here. So the story starts with some not so great news. Back in 2010, the earthquake in Haiti, which many of you will remember, affected hundreds of thousands of people, and many tens of thousands or possibly hundreds of thousands of people lost their lives in that earthquake. There was a major problem there, that in the immediate aftermath, many government institutions were destroyed, and the responders who were coming into Haiti often didn't know which areas and which neighborhoods were most affected and where people needed help. So let me play you a little video, and I'll explain afterward what it is. So that's the earthquake taking place. And as you see these little flashes of light, These are not aftershocks. These are actually volunteers all around the world who are creating an open map of Haiti using OpenStreetMap. And each of those flashes is an individual edit to the map that a volunteer is making. So what did we end up with? On the left here, you're seeing the map in the surrounding area around Port-au-Prince before the earthquake took place. And then on the right side, you're seeing what the map looked like in the incredible detail that was filled in by hundreds of volunteers who came together online using OpenStreetMap. This is just 18 days later, and this map had been provided in the preceding weeks directly to responders on the ground so they could navigate the affected area and locate people who are most in need of help. So around that time, as Joe had mentioned, these volunteers were coming together using OpenStreetMap, which is sort of the world's largest open geospatial volunteer project where people are working together to create super detailed maps of every location in the world. One of the challenges we saw after the earthquake in Haiti is that many people, they jumped online, they wanted to help, but people were working in the same areas and editing the map in the same areas. So we had this idea, we need some sort of a coordination tool. And that's what you're seeing on the screen here, is that we created a product called Tasking Manager, which basically just gridded out the map and allowed each volunteer to work on a discrete section of that map. So what happens, this is a little bit kind of a look into the process. A volunteer is presented with satellite imagery sitting at their laptop. They essentially trace over what they see, so the buildings and the roads, so they essentially digitize from a satellite image. And let me just go back here. Yeah, and so what you end up with is sort of vector data that then you can analyze, you can use in GPS devices for navigation, you can print out. The challenge we have today is that we're still facing the Haiti 2010 issue in 2018. In many places around the world, if you open them up on your whatever map app you use on your phone, you'll see that there's, in rural areas, there's often just big empty spaces, big areas of gray or of tan, depending on what map you're using. And these are often the places most vulnerable to disaster. So why do we care? Why do maps even matter during disaster? Well, they help us answer some of the most basic questions. Things like, what area was affected? What supplies are needed? Who's most at need? And it helps us get the right people and right supplies to the right place at the right time. So the maps that are generated by volunteers are directly used by responders such as Doctors Without Borders or the Red Cross on the ground as they're providing relief. And this is all happening through the OpenStreetMap project. So what is HOT? So my organization is called Humanitarian OpenStreetMap Team, HOT. And we work to coordinate this global effort of volunteers around OpenStreetMap. So, so far since the earthquake in Haiti, we've had 100,000 volunteers work with us over the years. And they represent not just people here in the United States, not just in DC. These are people all around the world who are contributing from their countries, helping people affected by disaster in the same country or in other countries. So since 2010, HOT has used this tasking manager tool to coordinate the volunteer effort in more than 50 rapid responses. And you can see them a little bit small, but you can see them on the screen. Some of the most recent ones were the Caribbean hurricanes last year. And we're currently responding to the volcanic eruptions in Guatemala, Hawaii, and several other ongoing events. So this is what the tasking manager looks like. I encourage you all to check it out. You can go to our website is hotosm.org. And this is all powered by AWS. So we use Elastic Beanstalk to scale rapidly post-disaster so that when our tasking manager is hit by hundreds or thousands of volunteers, we can scale dynamically to meet that need. So last year, Puerto Rico, Hurricane Maria. Thousands of mappers responded, and they came together in using this tasking manager tool, and AWS helped us scale to meet the demand. So what I love about this photo is that the maps created in OpenStreetMap were directly used in response efforts on the ground in Puerto Rico. So if you take a close look, all those maps printed out on the wall there are created directly from what volunteers were doing in OpenStreetMap. And these are some of the teams, FEMA, FDNY, and the Red Cross in a coordination center on the ground. So I mentioned this before. We still have the Haiti 2010 challenge in 2018. This is a photo from just last month that our team took in Tanzania, Dar es Salaam. So we're working in several other countries, and this is unfortunately not even a major disaster. This is ongoing seasonal flooding that occurs every year. You can see many of the homes in this one neighborhood or ward, Jangwani, were severely affected. Over a dozen people died, and dozens or even hundreds of families were displaced during the event. So one of the things we're doing in Tanzania is working with communities to teach people, local government officials, students, and community members how to address these challenges of ongoing disasters and ongoing flooding. And one of the ways we do that is by actually capturing aerial imagery using drones. So what you see on the sort of inset photo on the bottom right there is a SenseFly EB drone that community members flew over nearly, nearly the entire city in Dar es Salaam, capturing aerial imagery over their city. And then they use that imagery to do the tracing process I showed earlier, where they're essentially creating the buildings and roads in OpenStreetMap for the first time. So what you're seeing here is a time lapse of how the map gets filled in. And this is what it looks like at the beginning. So just big swaths of gray. But you can see it doesn't match reality. When people start drawing in what actually exists on the ground, there's just an incredible amount of detail that gets filled in. These are people's homes. These are health facilities, schools, shops, places of worship. And this is all happening through, this is just another before and after. So you're seeing what the map looked like before, and then as that slider goes across, those are all the buildings that were in that same neighborhood. So roughly 6,000 buildings were added in just a couple of weeks. This is just one neighborhood. So it really shows you the power that volunteers can have when they come together and are focused and coordinated using some of these online tools. After they did that mapping process, so we have a map, then what? So the thing that happens next is we start to use that map and use that data to respond to disaster. And the maps here highlight some of the areas most prone to flooding. And these are places that the communities identified either through surveys or by drawing sort of polygons on the map where they felt were most prone to flooding. So I mentioned the process where communities collect imagery using drones. And Joe mentioned this earlier as well. One of the tools that we use after that imagery is collected is Open Aerial Map. So Open Aerial Map is sort of a one-stop shop where you can go to search, find, and use open imagery from satellites and drones. And we highly leverage AWS services like AWS Batch to make it happen. So as drone operators are collecting imagery, that imagery gets processed and then uploaded to Open Aerial Map, and Batch is used to create TMS, or tile map services, that then allow our volunteers to trace that imagery. And so I'll finish up here, and I'm just going to leave you guys with a little video of how Open Aerial Map is actually working, and then I believe we have a few minutes left to take questions. Excuse the shaking. It normally plays without the jitter. Okay, thank you guys. So we'll finish up there, and then I believe, Joe, do you want to come up and take some questions?
Yeah, thank you.
Okay.
I think it's coming here in a second.
No? There we go. I'm sure I'm not the first person to ask this question, but you basically said, the OpenStreetMap guy said, we do aerial drones, and we get these strips, and then we divide them into grids, and then we give them to these people, and they do it. And here we are, we have the same problem now. Actually, we don't. If you've done all that, and you have years and years of these grids that were not annotated, and then they were annotated, surely somebody could take that data, because there's no difference between this neural net and the people that aren't even subject matter experts and they're doing it. Has anybody trained it? Because these are very difficult ones. These are really difficult. I mean, they're like submerged, but clearly people can do it. So has anybody used that kind of training data in these very difficult situations? You've got tons, it sounds like, of grids, which could be chopped up into further chips that could be sent off to segmentation maps. And has anybody done that so that we don't need people in the loop to do that and we can do it a little quicker?
Joe, do you want to talk about some of the machine learning
Yeah,
efforts?
so, I mean, I'm not going to give you, I'll just caveat this with saying this isn't the best answer, right? There's actually people who maybe just raise your hand real quick, because there might be people in the audience who can answer better than me, and they'll find you afterwards. So just put your hand up real quick so they know who you are. No, you put your hand up. They'll find you afterwards. Yeah. But I will say, I think, and this isn't going to be specifically for HOT or Open Aerial Map, but I mentioned SpaceNet as one group. Development Seed's doing a lot of work in this area. But there's other training data sets that are trying to get at these problems, like the XView data set that has an active challenge going on right now, which is specifically designed around disaster response. So I think there's a number of groups doing that. I don't know that they're currently working with the type of data that would come out of OAM. They're working on high-resolution satellite imagery. Most of them are working with Digital Globe worldview data. So there could be a place for drone imagery, certainly. I just don't know that the groups have done that, but people might have different answers.
Yeah, Joe, if I could just add a little bit to that. So I would also say, yes, we want to make this process faster, better, and less cost and resource intensive. It doesn't mean necessarily taking humans out of the loop entirely. I think the way we see it, at least on our side, is that we want to augment humans and make them more effective at their jobs. So maybe for example, drawing a square around the building might not be the most effective use of somebody's time. But there is local insight that can't be sort of replicated or duplicated by machines. So a lot of our teams that are working on the ground, for example, are capturing things that you can't see from the air, like what's the use of a building? Is it a school? Is it a health facility? What's the name of that store or that facility? And other things like street names and other types of local insights. So I would say for the remote mappers who are working on their laptops, yes, we want to make that process faster and better. For the teams on the ground, we're always going to need them to augment the data that's created from the sky.
One back there first.
Hi, my name is Daniel Vargas Benitez. I was born in Puerto Rico, and my mother lives in Puerto Rico, and we have family in Puerto Rico. So on behalf of myself and my family for what's being done for mapping in Puerto Rico, I just want to say thank you. My question is, so I went and got Mom out of there right before Maria hit. And just like people from the old country, she's dying to go back no matter what's going on. So when we land in San Juan, we have to drive 2.5 hours to the southwest corner of Puerto Rico. It's called Cabo Rojo. So I'm wondering first, and this may be for personal reasons, but it's applicable. Is the mapping, has it been completed, okay? And to what level? Is it at the street level? Because there's a lot of areas that still are leveled and need cleaning up. And when driving from San Juan to Cabo Rojo, you know, and if we're trying to GPS the best way, I mean, I know how to get there, but a lot of times with traffic and, you know, applications like Waze and stuff can get you around certain situations. So are you able, is that applicable? I mean, the mapping to the GPS and can you expand a little bit on that?
Sure. So yeah, I guess my first comment is thanks for the question, and I recognize and acknowledge the struggle that a lot of people are still experiencing on recovering from the hurricanes, especially Maria in Puerto Rico. I would also say maps are not the ones on the ground saving lives, but the way we see it is that if we can make the people who are on the ground working in rescue, recovery, and restoring basic infrastructure to Puerto Rico, if we can make them even 5% more effective at what they're doing through the use of data, open data and maps, then we see that as a sort of mission accomplished. So that's really what we're trying to do, is make people a little bit more effective, a little bit better at their jobs, and a little bit better able to get the right people and right supplies to the right places at the right time. So in terms of navigation, that's one important use of maps. There's other uses as well. So some of the stuff we're doing is just providing a base map so that as through recovery efforts, we have a starting point and we can start to indicate which places are still damaged, which roads and buildings are still damaged. So what we're doing is like that very basic first step of just creating something that you can start to analyze. In terms of navigation, yeah, Waze is a great tool in many places. It doesn't work on OpenStreetMap data, so there are other apps that you can put on your phone that work with OpenStreetMap. So I'll just mention one of them. It's called maps.me. It's a really easy one. You can download it, and you can use our maps offline in whichever location you're traveling to. So check that one out. Maybe it's useful.
Okay, I just want to say thank you, and God bless you. Thanks.
Thanks. Hi, this is Ethan McMahon from the U.S. Environmental Protection Agency. I think all this stuff is terrific, and I'm a big advocate for open data. However, I might have watched too many movies. And I'm thinking of what all the bad guys could do with all this information. Getaway routes, where to hold the heist, how to stop government relief from reaching where it's supposed to go. All kinds of bad things could happen. So how do we balance that?
That's all you.
Look, this is a question that comes up a lot, and I think people have different takes on it, first of all. So let me just preface what I'll say with there are different approaches to this. My personal approach is that first of all, not all data is meant to be open data. The stuff that we put in OpenStreetMap is generally things that you can observe on the ground anyway. So physical infrastructure, roads, buildings. It's not, we're not sort of identifying individuals or households on the map. That's one thing. The other thing is that in terms of who has access to data, it's quite often that the bad guys already have an advantage over the good guys, so to speak. And what I mean by that is many of the places we're working in the world are some of the poorest and most vulnerable areas in the world, where literally the people who live in those places have never seen a map of their own town or village. And so the work that we're doing, the way we see it is we're sort of providing that capability for somebody to stand up and say, I'm putting my home, my house onto the world map for the first time. I exist. And that's a really powerful statement. Now, there's also risks to that, right? So what happens if I put my village on the map for the first time and I live in a slum or an unplanned settlement that's not supposed to be there? So there's risks to that. The way we usually handle it is that we're not doing things in isolation. Our organization works with local partners on the ground, and before mapping communities, we make our best effort to actually work with those communities and make a conscious decision of whether they want to be on the map or not. So I think there's a lot more to talk about here, but I think that's probably our biggest sort of core value, is that we do everything in a participatory way so that communities can make the choice for themselves.
How are you all ensuring data accuracy? And the second part is, which drone do you all recommend? Is it on your site?
Yeah, in terms of which drone we recommend, we have some really good people in the room who'd be better answering that than I would. However, I would say it depends on sort of what your purpose is and what you're trying to do. So the ones I showed earlier in Tanzania were what we call fixed wing drones, which cover sort of large areas and help you image a large area at one time. There's also the quadcopters, which you guys have seen, which are sort of that under $1,000 drone, which it's a little bit more affordable than the one that I showed in the video earlier. So it really depends on what you're trying to do. And then, yeah, mapping. Yeah, so if you're trying to cover large areas, the fixed wing drones are really good for that because they can sort of image over a very large area, but the cost is typically higher, so that's the trade-off. And there's also trade-offs in terms of how long they can stay airborne and all of those things as well. So, and could you repeat the first part of your question for me?
Data accuracy.
Yeah, data accuracy. So we, as our data is mostly volunteer generated, we have a sort of two-step process. So volunteer one does mapping, then we have a second more experienced volunteer who comes in and does what we call validation, which is basically they take another pass over the same area. And then the great thing about a project like OpenStreetMap is that it continues to get better over time. So if you guys remember what Wikipedia looked like 10, 15 years ago, you know, it was sort of bare bones. Not too many people were trusting it at that point. But the accuracy today is incredible. And why is that? Because so many people have contributed to the project and so many people have edited Wikipedia articles. So the same thing's happening in OpenStreetMap. Over time, we see, you know, there's some bad actors. There's some people who are malicious or create erroneous data. But over time, those things get cleaned up really, really quickly. And there's also a lot of sort of automated tools that we use now to detect those errors and correct them extremely rapidly. And you want to add anything on drones, Joe? Or?
No, that's great.
So we have one more question over here.
This is just a follow-up on the question that the gentleman had, and I think putting it in a different way, I was wondering if there is any effort, and I know this is maybe kind of outside of the scope of what AWS does here in this context, but in terms of the disaster recovery, is there any kind of effort to combine this open public data with the efforts of the for-profit corporations, some of whom, like, you know, some of the efforts we've seen from Facebook seem to have shown interest in providing assistance or at least features that the users can benefit from during periods of disaster. So to follow on that question of, you know, whether it's Waze, Google Maps, or whatever map source, you know, some of these other private sources use, is there any effort to try to provide augmented data, like a road is washed out by, you know, flood or something?
Yeah, I can answer a little bit of that. I didn't really mention this so much, but at this event, we're sort of announcing our disaster response action team. So that's the AWS disaster response action team. And there's a couple components to this. And so to the actual data piece, that would always be done by customers and partners, right? Groups like HOT, groups like American Red Cross. What we're looking to do is make sure that infrastructure isn't a problem for them when they're trying to meet those demands, right? So I mentioned the American Red Cross case. We've also helped NOAA when they had peak traffic during a lot of the disasters last year. We helped them optimize their system so that their systems could stay online and they could meet their demand. We've also flown planes. We have planes, right? We have planes to deliver things. We're a logistics company. Amazon as a whole is a logistics company. So we have facilities where we can stage materials, and we flew planes into Puerto Rico and into the Virgin Islands with materials. And we also have an action team that can be deployed. We have about 20 plus volunteers that are trained in the National Incident Management System, CPR and first aid, that can be deployed when we're asked to go to help around connectivity solutions to help communities get back faster, right? So we are definitely interested in helping. We would do that through partners and customers and just trying to make sure that they're most effective, I'd say.
Hi, Jeff Dedebush of the York currently with NOAA. So two things. Yesterday I saw Seth, I think his name is, upstairs at the booth, and he was explaining the snowball edge. That was, I think, the most cool thing that I've seen at this workshop. You know, I mean, the tech is great, but this kind of really helpful thing is just awesome. So I'm really glad you guys are doing that. And then in terms of the OpenStreetMap thing, I was wondering, do you do a lot of kind of pre-disaster stuff? Like I think about, there's the SciDataCon meeting in Gaborone, Botswana coming up, or sometimes the geoplenary is held in a developing nation which may not have as good mapping. Have you ever thought about organizing kind of in conjunction with one of these events, let's make some mapping happen while we're there. And then second part of the question, what about a little bit more crowd, non-official sourcing, in countries you haven't served? Like I was looking at Madagascar, very few things there. Can people there be brought in, or do you need more expertise already on the ground?
Yeah, so for the first question about events, yes, great suggestion. We love to do that kind of thing. We do this thing called a mapathon, which is like instead of running 26 miles, you're sitting at your computer mapping. So we get a lot of people together in a room, and we have, it's kind of a social event. We have drinks, pizza, et cetera. And we try to do those things at conferences too. So yeah, it's a great suggestion. We actually have a team on the ground in Botswana right now. And also, yeah, the geoplenary, I think we'll be trying to figure out what to do there as well. So yeah, but definitely. And then in terms of involvement, if I understood the question correctly, we welcome everyone to get involved. There's sort of no barriers to entry. So individuals can contribute, and also we have, tying into the earlier question, we have a lot of really wonderful corporate partners who are supporting us. As a nonprofit, we really rely on that type of support. So AWS is one of our key supporters. And we have a number of others, like Digital Globe has a really great open data program that they support us sort of post-disaster. But yeah, pre-disaster too, we're also working on, we have a project called Missing Maps, which is sort of identifying vulnerable areas before disaster happens and trying to target those areas. And for volunteer groups on the ground, we sometimes work with them to provide them training or some equipment so they can join and participate, even if there's limited resources like low bandwidth, or they don't have money for internet, or don't have laptops. So we try to enable, get past those basic barriers so that anybody can join in the project and contribute.
We have time for one more question.
Hi, yes. The question I have is, we are part of a water district in Southern California, and so one of the things that I'm very curious about, not only from a drone standpoint, I mean, drones are of course the way where you get imaging, but how you would actually have a lower cost option for something like via cell phones, where you're kind of crowdsourcing it in the sense of the people who aren't in immediate danger, but actually able to use their cell phones to go and provide you with imaging to update maps and things like that, and if that's an effort that's going on, or something that's developing.
Joe?
Yeah, I mean, I'd say yes, it's definitely possible. I'm not going to remember the proper name of the group, but it was like the Shake Me Sense. It's for earthquake sensing. They're basically using, it's a citizen science thing where people can use their phone to say if they detected an earthquake, and then it all goes back somewhere, gets collated, and then it can lead to better reporting. I think there's a number of projects like that. Technically, it's totally all doable. I think you can do it potentially without external connectivity, right? Depending on how it's all wired up. But yes, I mean, I think from that angle, it's all possible.
Yeah, there's other ones too, that focus around social media. So we have a partner in Indonesia that we work with where as flooding occurs, people can tweet, it would put the hashtag flood in their tweet, and then all that data gets aggregated and sort of visualized for disaster managers to respond to. So yeah, there's these really amazing, I find out about new ones every day. There's really amazing projects like this that sort of are sourcing stuff other than we're focused on map data, but there's others who are focused on sourcing some other type of information from citizen volunteers. And geospatial is now integral to all that, because whatever is being sourced, you need to have you need to have a geotag so you know where it's coming from. But it might be, it could be a tweet, or it could be sensor data or something else.
All right, thank you very much. Excellent presentation. Thanks everyone for attending. Please remember to share your feedback in the survey portion of the app. Lunch will be available up in the Solutions and Expo Hall from 12 to 1, and then the breakout sessions will resume again at 1 o'clock. Thanks very much for coming.